Hi, this is Tom Loschiavo, Chemistry Education Manager at PASCO Scientific, and I am here today to talk about the absolute zero apparatus. This is a great tool for studying the concept behind absolute zero. You can measure pressure and temperature in a constant volume sphere, and you can use that relationship between those two variables to get the idea behind the Kelvin scale. So I'm going to plug this into my chemistry sensor, and I'm going to put that into my SparkLink. So I'm going to build a page to look at the relationship between pressure and temperature. So I'm going to go to Build. I'm going to look at temperature and pressure in a graph. And I also want to monitor those two values. So I'm going to look at them in a digits display. Temperature in the digits and pressure in digits. So now I'm almost ready to start collecting data. I want to do this in manual sampling mode. I want to make sure my values are stable before I collect the point. So I'm going to change the sampling option to manual. Okay, now I'm ready to start collecting data. So I'm going to collect 3 data points. Room temperature, in a cold bath, and in a hot bath. I'm going to hit Start. And I'm just going to leave this in the room and monitor the temperature and pressure to make sure that they're stable. I can also look at the little dot over here to make sure that isn't moving around too much on the graph. And it looks like we have a pretty stable condition right now. So I'm going to hit Keep to save that point. And now I'm going to put this into my cold bath. And I want to make sure it's completely submerged. So we can see the temperature and pressure are both dropping, so automatically we can talk about that relationship. And I'm going to auto-scale this graph. And my first point is up here, and my second point is down here. And we're going to fast forward the video a little bit as the temperature and pressure equilibrate. Okay, it looks like we've just about equilibrated. I'm just going to give this a couple more seconds, and I'm going to hit Keep. So now I have 2 data points. Now I'm going to put this into the warm bath. Again, I want to make sure this is completely submerged. And we can see the point on the graph is rapidly rising as the temperature and pressure inside the sphere attempt to equilibrate with the warm water. So once again, we'll give this a little bit of time as the temperature and pressure equilibrate, and we'll fast forward the video. Okay, looks like we've just about equilibrated. So I'm going to hit Keep one more time. And now I have my data. I'm going to stop data collection. And just from the lines on the graph, we can see the relationship between pressure and temperature. But we can go further than that. We can analyze this by doing a linear fit. So I'm going to put a fit line on there. And now we have a nice fit line through those points. And this time it looks like the intercept is about -257. So here's where we can start getting, with our students, getting into the idea of what an intercept means and what that means in terms of the temperature scale. So just to get an idea of what that means, I can rescale this graph to show what an intercept actually is. I'm going to shrink these down a little bit. And now we have the intercept displayed. So we can talk about the concept behind the absolute zero and the Kelvin scale as being the place where you can't go lower than 0 pressure. And in this case, with our measurements today, that's -257, and we know it's supposed to be -273. But In the 4 minutes of data collection, we got a very good relationship between pressure and temperature, and we're able to show the ideas behind the concept of absolute zero. As an added extension, we can actually change the scale on the graph to reflect temperature in Kelvin. So we can open up our graph and change our y-axis to the Kelvin scale. And we can put that fit on there again. And now we're not quite at the origin, but we're close to the origin, showing that the temperature scale in Kelvin, 0 on there is the absolute zero temperature that we can have. So this absolute zero apparatus is a great tool for looking at the relationship between pressure and temperature, for getting to the ideas behind the Kelvin scale and absolute zero, which is something that students always question. How do we know? So this has been Tom Loschiavo, Chemistry Education Manager at PASCO Scientific. If you have any questions or comments, please reach me at chemistry@pasco.com. Thank you.